Good day, everyone. My name is Tim Hansen. I'm a technical support engineer here at Sophos, and today we're going to be looking at how to connect to a Sophos UTM on AWS using L2TP. So the information in this video is going to be based off of a knowledge base article I wrote around a year ago, number 127187. And assuming you haven't already, should you want to take a look at this article, you can find it, of course, on our community site at community.sophos.com. In fact, I would maybe just recommend you at least take a quick look at it just prior to watching the video, just so you're not confused by any of the content we might be discussing here. Now, you might be wondering why we need a knowledge base article which explains how to set this up specifically on the AWS platform. Why can't we just use existing documentation that's already out there? So there's really a short answer and a long answer to this. And I'll maybe start with the short answer, just in case you don't want to sit here and listen to me talk about the long answer, or maybe you just are interested in the step by step and just want to fast forward. So, in short, L2TP over IPsec doesn't play nice when the server it's connecting to is behind a NAT device, or the server, or the UTM in this case, has a private IP address. Now, that's not to say that a client can't connect to a server that has a private IP address using L2TP, more so that this just happens to be the case when it comes to Sophos UTM. Now, the long answer. The problem isn't L2TP, rather, the problem is IPsec, or in specific, the Internet Key Exchange. Now, if you've tried to set this up on AWS, or you're in the process of setting it up, or you're planning to set it up, at some point you're going to look in the IPsec log and you're probably going to see something in there similar to this. Sending encrypted notification, invalid ID information. What does this mean? What does invalid ID information mean? Well, ID information is really referring to the identification payload sent between the client and the servers during IKE negotiation. So the purpose of the identification payload, or at least as it's defined in the RFC, is so the server can identify which IPsec policy to match the incoming connection request to. And I'll just note when it comes to the identification payload on the UTM, you're going to see this defined as the VPN ID. So how does this work? The UTM receives IKE packets from a client or a server or another appliance, and it's going to look inside those IKE packets and see two VPN IDs. It's going to see a VPN ID of the sender and a VPN ID the sender is sending to the server, or the VPN ID that the server should have. So in short, a source VPN ID and a destination VPN ID. So based on this, the UTM is going to take a look at its configuration, and it's going to know which IPsec policy to match the connection request to. And of course, once it knows that, it knows the authentication settings, the encryption settings, the pre-shared key to use, and everything should connect and get set up, or at least move on to phase 2. Now, for L2TP over IPsec, it works slightly different when it comes to matching of policies than it does with this, as opposed to the site-to-site connection. Now, that's not really important for the purpose of this video. What's important is how the UTM uses the VPN ID it gets from the client. So let's say we have a traditional UTM on premise. It's sitting on the edge of the network. It has a public IP address. The client is going to connect to the UTM, or at least attempt to connect by sending UDP 500 IKE packets to the UTM, and it's going to send it to the public IP address. So in this example, I've defined the public IP address of the UTM as 1234. So the client sends IKE packets to the UTM. Inside those IKE packets are going to be the source VPN ID of the client, which the UTM doesn't care about, so we can just ignore that, and the destination VPN ID of the UTM. The destination VPN ID from the client will always be the public IP address, or the IP address the client is initiating IKE to. Oop, I will go forward, not backwards. Okay, so the UTM, upon receiving IKE from a client, takes a look inside the IKE packets and sees there's a VPN ID of 1234. It will look at its configuration at that point, in specific its WAN IP address, and say, yes, my WAN IP address is 1234, and it matches up and it can proceed. Now, there's a little more to it. It's not as simple as that, but I'm just trying to keep things simple in this case. So if you're a developer and you happen to work with IPsec and you're noticing all the mistakes or any of the mistakes in this presentation, just excuse me. So on-premise, no problem, works as expected. How does it work, or how does it differ when it's a instance on AWS? So the client, to the client at least, the nothing has changed. The client doesn't care. It's going to send the same information. It's going to send IQDP 500 to a public IP address, and it's going to have a destination VPN ID of the public IP address. So again, in our example, it's going to stay at 1234. So these IKE packets hit the hypervisor's public IP address or elastic IP address. The hypervisor forwards it to the instance, in our case, the UTM. The UTM receives IKE, the IKE packets. It takes a look at the VPN ID, sees 1234, and then consults its configuration and sees its WAN IP address or its primary IP address. In fact, the only IP address or interface that gets created by default on the UTM. It's going to see it as a private IP address, or at least an IP address that differs from the VPN ID the client has sent. And this is where it errors out and gives us that nice invalid ID information error in the IPsec log. So what do we do about this? How do we work around this? Really, it's actually pretty simple. So there's a number of steps we're going to perform. Starting with on the AWS console, we're going to create an additional Elastic Network interface. So while I may refer to in the walkthrough as I may refer to the additional interface as a second ENI. If you've already configured a second interface on the UTM, that's fine. It's no big deal. You would just have to create an additional interface. So it could be your third, it could be your fourth interface. Just bear in mind that the family and the size of the instance will dictate how many ENIs you can attach to that instance. So if you're just testing the UTM on a T2 small instance and you already have two interfaces on the UTM, this isn't going to work. You're going to have to up the size in order to attach that third. So assuming you've got a additional interface attached on the UTM, you'll need to reboot the UTM. And the reason you have to do this is because the UTM's configuration daemon needs to be rebooted to pick up this new interface. So once the UTM is rebooted, in the web admin, we're going to create this new interface, and we're going to configure it to have the public or elastic IP address as is defined on the hypervisor or the AWS console. Once we have that new interface created, we're going to create a destination NAT rule. So IKE traffic that hits the primary WAN interface on the UTM is then going to get forwarded to this newly created interface. Fifthly and lastly, we're going to go into the remote access settings, and we're going to tell the UTM to listen for L2TP over IPsec on this new additional or second interface. And that's it. So what's going to happen is IKE is going to be incoming from the client. It's going to hit the UTM's primary WAN interface. The UTM will then forward that to an interface that has the public IP address or the elastic IP address on the hypervisor. So you can guess, obviously, what's going to happen next. The UTM is going to consult IKE. It's going to take a look at the destination VPN ID. It's then going to take a look at the interface we've told it to listen to L2TP over IPsec on. And because we've configured this interface to have the public IP address, the VPN ID or the destination VPN ID, and the WAN interface will essentially match up, and we won't get that error anymore, and presumably the connection should get established. So that's pretty much it. In principle, it's as simple as that. So why don't we go ahead and switch to the AWS console? I'll get my mug off the screen so you don't have to look at me anymore, and then we'll kind of walk through this and do it hands-on. All right, so the first thing we're going to want to do is to add the new Elastic Network interface on the AWS console. So go ahead to the EC2 dashboard if you're not already there. Scroll down and find network interfaces, and we can of course open that up and select create new network interface. I'm going to write something in the description which describes what the network interface is used for. So L2TP over IPsec interface. I suppose if you want to write a description or not is entirely up to you, but for me, I like to be able to readily identify things that I'm creating in the console, especially as environments grow and more objects, more instances get created. So for the subnet, of course, you're going to want to select the same subnet the UTM is deployed into. For me, it's US East 1A. Private IP address we can leave as is. Now, for the security groups, you can really do one of two things. One, you can use the same security group the primary WAN interface on the UTM is already using, or you can go back and create a new security group if you want to split things up. The important thing is, regardless of what security group you're using, make sure UDP port 500 and UDP port 4500 are open. So that, of course, will let IKE and NAT traversal through. Assuming you are good there, go ahead and create the interface. It should do immediately, yep. And then right click on the interface, left click on attach, and then select the UTM instance from the drop down menu. Once we select attach, it'll probably take 5 to 10 seconds to complete. And there we go. So now we've got the interface created on the console. What we want to do is we want the UTM's configuration daemon to be able to recognize that interface. So that will require us rebooting the instance. Now I've had mixed results rebooting it from the AWS console. So what I will do just to make sure I only have to do this once is log into the web admin and then reboot it directly on the UTM. So over to management, shutdown, restart, and reboot. So it'll take a few minutes for the UTM to reboot and then come back up. So what I'll do is I'll just pause the video until the web admin is accessible again, and then I'll resume things. All right, so my UTM has been rebooted and the web admin is accessible once again. So let's go ahead and log in to do the configuration on the UTM. So the first step we're going to do is to create the interface. So if we want to go over to interfaces and routing, then interfaces and click on new interface. I'll go ahead and name it as something logical, which will allow me to differentiate it between the other interface on the UTM. So let's do L2TP over IPsec. Of course, this is optional for you. If you want to name it something different, be my guest. The type we're going to leave default as Ethernet, and then the hardware, if you select the drop-down menu, you should see an available interface. If you don't, then probably one of two things has happened. Either you've attached the ENI on the AWS console to the wrong instance, or the UTM hasn't rebooted properly. So just check those two things. We can leave it to a static IP address, and what we're going to want to put in the IPv4 address field is, of course, the public IP address or the elastic IP address of the UTM instance. So for me, I've been assigned a 192.168.5, and then we can select a netmask of /32. Everything under the advanced field, you're probably going to want to leave as is. So go ahead and save that and then turn it on or enable it. And then if we refresh the page, we should see that the interface has come up. Perfect. So let's go ahead and move on to step number 2. So if we open up the network interface, or correction, the network protection section, we should see where we're going to create our NAT rules. So let's click on that and then move over to the NAT tab. Creating the new NAT rule, we're going to want to make sure that the rule type is set to DNAT or destination NAT. For the traffic from field, you're probably going to leave this set to any. So the only exception to that would be if you have a client or clients who you know are going to be connecting from a static IP address or to a number of static IP addresses, in which case you're either going to want to just create a single host object for that IP address, or if you've got multiple IP addresses, what you can do is create a network group, and then within that network group, create as many host objects as you need. So I'll just cancel out of here and of course just leave this to any. For this service, what we can do simply is to find the IPsec group and drag that on over. That'll ensure that we have the two protocols or ports that we need open, that being UDP 500 for IKE and UDP 4500 for NAT-T or NAT traversal. We're going to grab the green WAN address object from the UTM. So unless you've changed this previously, the default is going to be internal. I mean, that's not very logical, obviously, but regardless, it's going to be called internal and then address in brackets. So go ahead and grab whatever the WAN interface object is for you, grab that, throw it into the going to field. For the change destination to, we're going to want to grab the interface we just created. And herein lies the benefit to naming it something that differentiates it from other interfaces. So let's grab that and throw it into there and select automatic firewall rule. If you want to get granular with your firewall rules, you can leave this unticked and then just manually create a firewall rule after. For me, I'll leave this to, or set it to automatic. Okay, so once that's created, we can go ahead and turn it on and then move on to the last step. So the last step on the UTM is going to be to set our L2TP configuration to be listening on that new interface we just created. So in remote access over to L2TP over IPsec, we can see our interface is our internal or our WAN interface. So if we grab this and then switch it over to L2TP over IPsec or the new interface, whatever you've named it, and then don't forget to hit apply. Okay, so we can see the setting has been changed and effectively we're all done with the UTM configuration. So what's going to happen now is the IKE packets are going to arrive from the client to the normal WAN interface on the UTM. At that point, the DNAT rule will come into play. It'll take those packets and send them to the interface we created, which is configured to have the public IP address of the UTM. So now L2TP, since we've told it to be listening on this new interface, once the UTM analyzes the VPN ID, it will see the VPN ID as its public IP address and match it up to the interface that it's been told to listen on. So just to prove that this actually works, I've set up my VPN connection previously. If you're looking for a detailed how-to guide on how to set up L2TP on the UTM as far as the settings here, and additionally how to set it up on your local device or local computer. I'll just flash a URL on the screen here for a guide on our community site. Okay, so like I said, just to show that it actually works, I'll go ahead and select my VPN connection. Actually, why don't I open up the live log first? And once the live log is open, then I'll select my VPN connection. And what we should see here is we should see it connect, and we shouldn't be getting that invalid ID information error anymore. Beautiful, so that's that. So we can see the connection has started, and then if I look under my interface settings, I can see the VPN connection is connected. Okay, so that is pretty much it for the step-by-step, and I suppose that's it for the video as well as a whole. If you happen to have any comments or questions, just add them below in the comments section. Otherwise, thanks for watching, and we'll see you next time.